what I guess we mean by visual intelligence is very context aware kind of AI that can use what's happening and being seen through a video camera visually to really assign a lot of very high level abstract, not abstract, but let's say very important meaning to what is being seen. And specifically, let's say, is there a value add activity happening right now? Is there value add work happening? In every operation, there's going to be times when there's really strong performance happening, there's excellence happening, and other times when it's not happening. And just being able to tell that apart by looking at not just what the people are doing, but what, let's say, the machines are doing, what's happening in the environment. Maybe there's a red light on some machine. Traditional neural networks, they are really great at finding patterns in space and time. They have some weaknesses, which are becoming clearer and clearer, I think, to everybody, whether you're using ChatGPT or some other neural network system. And that is that.
Welcome to the Industry for Audio TV podcast. I'm your host, Kudzai Manditereza, and today we will discuss visual intelligence applications in manufacturing, and I'm joined by Cyrus Shaoul, the CEO of Leela AI. Cyrus, welcome, and thank you so much for taking the time to join us on the show today.
Well, it's my great pleasure, Kudzai. It's a great show. I've watched a lot of your interviews, and you do a great job. It's really fascinating stuff. So I'm really honored to be here.
Absolutely. Thank you so much. So to kick things off here, maybe could you introduce yourself to the audience and tell us a bit more about Leela AI?
Sure, sure. My name is Cyrus. I'm one of the co-founders of Leela AI. I'm the CEO, and our co-founding team, started this business because we felt like there was this big gaping hole and a big need out there to solve problems in the workplace and in environments, and particularly manufacturing environments. One of our co-founders, Milan, came from a manufacturing background, manufacturing electronics and LEDs, and she knew that this was a really giant problem that needed someone to approach it. That is, how to use visual intelligence to make things work so much better in operations in manufacturing. And so, we come from different backgrounds, a lot of MIT people on our team, the three founders, all of us met at MIT. So we have that, background personally in doing lots of software stuff, AI stuff. And then we also have manufacturing on the team. And so we brought it together and started working on this and delivering a product back in 2022. And the real driver was that we knew we could really deliver value, and we see this. Without visual intelligence, there's no way you can gather this data. This is super super critical, valuable data about the whole operation. There's the machine data, and then there's the rest, and that rest is something that has not been easy to collect data on. They've tried many things, but without that data, it's so hard to optimize the whole process and to really improve and find excellence and elevate excellence across the whole manufacturing operation. So, that's where we jumped in, and we built a system that does that. It gets that data, super high quality, high fidelity data. And then we deliver things like we deliver 20% improved capacity on lines. We deliver, 30% reduction in overtime hours. We deliver 50% reduction in reportable incidents in safety issues. And we've delivered 10% improvements in yield. So that's sort of the big picture, that a lot of business value if you can see what's happening and if an AI can help understand what's being seen and then take actions based on that. That's the core right there.
Awesome stuff. Thank you for that introduction. So I kind of like want to sort of like take a step back here. There are two things that I want us to start with.
Sure.
Um, Firstly, when we talk about visual intelligence, what exactly do we mean? Because as you would know, there are lots of forms of visual recognition that have existed in manufacturing for a while now. And secondly, I would like you to sort of like paint a picture for us on what are the real opportunities here for manufacturers to drive business value with visual intelligence.
Sure, sure. So, a lot of manufacturers have experience with using computer vision, as it was called, and now machine vision and AI supported machine vision. So all of that is been used for a while, but mostly it was used for, let's say, product inspection, looking for defects or anomalies in physical things by just taking pictures of it and then analyzing those images. And that's been extremely valuable and still valuable and is continuing to grow. What we saw is that there's another kind of intelligence which goes beyond just looking at a product, but actually looking at a whole process. And that's where we came up, or not us, many people have used this word like visual intelligence. And it means that to us, it means using machine vision to intelligently understand the meaning of what is being seen. And the meaning is very important because, things mean different things depending on what's going on. In one moment in time, in one location, something happening means something. And then in another point in time, in a different location, it means something else. The exact same thing could be happening. And so what I guess we mean by visual intelligence is a very context aware kind of AI that can use what's happening and being seen through a video camera visually to really assign a lot of very high level abstract, not abstract, but let's say very important meaning to what is being seen. And specifically, let's say, is there a value add activity happening right now? Is there value add work happening? That's the kind of thing. If you say, I can visually tell when that's happening, that's really to us the critical point of crossing the line into visual intelligence. And that's what we do. So yeah, that's the real important thing to understand is visual intelligence is looking at what's going on in the world and including across time so that you can understand the meaning of what's happening. Does that make sense, Kuzai?
Oh yeah, absolutely. So maybe to kind of like clarify a bit on that. So I saw on your website, I watched a little video clip on your website where essentially a video camera was kind of like watching machine operators kind of like do their jobs and things like that. So
Yeah.
basically, what you're saying is you're kind of like deploying these visual system that kind of like monitor or track, and is it mostly to identify patterns? What would you say are the lowest hanging fruit as far as just watching people do their jobs? What is the most immediate value that you think
Yeah,
you
the most
want to get?
immediate value is understanding the sources of great performance. And so, there's in every operation, there's going to be times when there's really strong performance happening, there's excellence happening, and other times when it's not happening. And just being able to tell that apart by looking at not just what the people are doing, but what, let's say, the machines are doing, what's happening in the environment. Maybe there's a red light on some machine that is important to know, and then looking at whether people are doing a lot of walking, if they're searching for parts in a parts bin, if they're having trouble making their tools work correctly. All these kinds of things are things that are not going to contribute to the excellence. So you want to figure out what is causing that drop and what is causing it to be excellent. And so that's our performance idea, that we can support improving performance by being able to understand visually this interaction between people and their environment, the machines, robots, whatever is around the people. We have to look at it holistically as a unit, and having the visual system see everything, you get that holistic view. So that's sort of does that make sense in terms of the first part? I mean, there's other stuff too beyond performance,
Yes.
but that's sort of where we enter a lot of conversations is how do we find excellence in an operation and always find it and elevate it. Does that make sense?
Yeah, absolutely. I mean, we're going to go into the use cases in depth in a while here. So maybe
Yeah.
before we jump into that, just kind of like talk about Leela Visual Intelligence platform to kind of like really understand what it is that you bring here. So what I would like to find out is what specific problems does Leela AI solve for manufacturers using visual intelligence? And could you explain to us exactly how that works?
Sure, sure. We intentionally started this with the idea that, if we were just solving one problem with one sensor, that would that would be great. But if we could solve more than one problem with the same exact sensor and really create many, let's say, artificial or synthetic sensors from one real sensor, then we had something of greater interest. So we address three problems simultaneously. We address as we said, performance and getting excellent performance. We address safety simultaneously because everything that you're seeing for performance, if you can see the safety activities, whether they're risky, hazardous, and help reduce accidents and near misses on the job, that's a second benefit. And then the third one is quality. And there's a lot of quality issues that are not visible at the end. They're only visible in the process. And so that's the third. So, we said we're going to do all three. And it's a big challenge to jump in and try to do three things at once. So we had to invent our own core technology engine that could handle three different types of requirements with one pipeline. But we have that. We've built that, and it's really been quite satisfying to see how it's delivered these benefits for these manufacturing customers we work with.
Awesome. So I know like the core really of your platform is visual intelligence, or the technology behind your platform is the visual intelligence.
Yeah.
Is there do you augment that also with sensor data at some point, or is it purely visual intelligence with no sensor, some other forms of sensory information?
We actually do incorporate, we have an open platform. So any kind of sensor data or other signal that can help us, we can incorporate that. And I'm going to go into a use case, I think, in a minute where I'll give an example of where we used an external data source um, to augment the visual side. Because, there are some things that are visible and other things that are invisible but important to understand context, right? And so that's when we really need to bring that in. And actually, MQTT, to throw in our favorite four-letter acronym, MQTT has been really pivotal for us in being able to do that quickly and easily. So I'll also be able to dive in and explain how that works for us. So yeah, let's get into some use cases, some specific, stories about, what we were brought in to do, what we did with customers, and maybe that'll clear that up. How does that sound?
Oh yeah, absolutely. I think to kind of like really help our audience deeply understand the impact that visual intelligence has or could have on manufacturing operations, it would be useful to kind of like look at some of the real customer stories that you could share with us. So yeah, let's
Yeah,
jump into it.
yeah, yeah. So, one of our customers, they build large complex machines, and so their assembly process could take somewhere between 1 to 4 hours and sometimes longer, depending on what model they're building. And they make many different SKUs and many variations. So it's very much a high mix type environment, and that is, I think, common in especially in the USA. There's a lot of strong high mix manufacturers that have to deal with a lot of variation. So when you have that much variation, you have a lot of manual steps in the process. There's a lot of opportunity to find ways to, find where that excellence is happening and figure out how to, improve the performance. So they're using us for this performance. We call it the performance module. They're also doing some safety stuff too. So we can apply both modules to their workstations. And so their challenge was they have production targets that are driven by orders. And so to keep a really good customer satisfaction level with all their customers, they need to deliver these products on time. And they had a problem. They were not able to get them out fast enough, and the order log was growing, and the wait time was growing, and there's a lot of frustration on the part of their customers. So they came to us and they said, "We need your technology to understand, because most of our work is manual, and there is, let's say, there's not a lot of MES activity in those areas that are manual, right? There's not a lot of investment yet in those kinds of scanners and computer interfaces. They're still building things the way they have for a long time. They said, can we do this without having to do a very expensive, long, complex MES and ERP implementation in these areas of our factory? And so that's what we did. We implemented the visual intelligence. We were able to collect this valuable data they couldn't get any other way. I mean, you could get it if you had a clipboard and a stopwatch and you were doing a classic time motion study, but you'd have to stand there for weeks watching 24/7 this area to really get enough data to make these kinds of judgments and decisions. And so we put our system in. We found out when the standard operating procedure was being followed and when it wasn't. And by pushing everybody to follow and to use the SOP, that provided some really big gains in their efficiency and productivity. They also had their, that's more of a supervisory usage. There's also a industrial engineering and manufacturing engineering usage where you can take this big data set and build a really high fidelity and very high resolution value stream map. How is time being spent every second of every day in this area or in across the whole line, right? And then where are the bottlenecks forming? So that's also what we did with them, and they were able to analyze that and build this new value stream map, and then figure out how to improve the value stream so that there'd be less non-value add time spent. And so, we surfaced wasted time, we surfaced bottlenecks in their process, and they were able to increase their capacity by 20%. And that's made all the difference. Now they're catching up on their production. They're hitting their targets more frequently, hourly targets, daily targets. And that was because they had this data that they'd never been able to get before.
So for this specific use case, I want to get a sense of the time. How long did it take from the time you sort of like implemented the solution to when they started to get value out of it?
Sure. We implemented the solution, let's say on day 0, and by day 30, they had a very clear signal coming out of the dashboards and the visual agents. We call them visual agents because they're looking for things like looking for walking above threshold of walking and looking for other kinds of non-value add activity that's excessive. So the visual agent started working after 30 days. By day 60, they had been doing now daily kaizens based on the data that we were feeding them back every day, and they were starting to see some improvements. And I think by day 90, we started to actually see the capacity grow. And so I'd say, that wasn't maybe the full 20% increase in capacity, but in the next month or two, they hit that 20% improvement in capacity, and they've been holding that steady since. So that's the kind of pace of improvement that we've seen with all of our customers. Very, very similar.
Awesome stuff. And do you have other use cases, perhaps in the so you mentioned you kind of like in the safety, you deliver on safety, quality, and performance. Do you have some other use cases, perhaps on
Yeah.
safety? Yeah, sure.
Yeah. One of our largest customers does metal casting, and it's very dangerous. There's hot metal, liquid metal, moving around. There's potential for explosions and other kinds of accidents. So there's also environmental exposure risks. Could be some particles in the air that people might breathe if they're not wearing the right breathing equipment, and other risks. And if someone does get ill or has something else happen, they might just sort of become unconscious and lie down. And they want to be able to know if someone's working alone and they're down, there's a person down, they want to know that right away because there's not always somebody else around to see that. And they need to know fast. So we started with our first drive and push to improve their safety posture by putting our system in and using our safety module to detect PPE compliance. And then also certain other compliance issues, like, let's say there's a certain part of the factory that when there's something happening, there shouldn't be more than 2 people there. Too many people is dangerous. So we can also check for overstaffing for safety. And then, of course, person down and all the PPE, all the clothing, heat resistant clothing, all that kind of stuff. We set that up so that they would get alerts on any of those immediately. They also get all the historical data. So you can say for these different parts of the area, what's their trends over time in terms of compliance? Was there some hotspots of non-compliance and other hotspots of compliance? And then the other thing we did was we put a big sort of scoreboard on the wall where everyone who's working there can see. And that actually was very powerful because there's a psychological impact of saying, sure, I know what that I was working safe, but how's my team doing? How's my shift team doing? How's this whole team doing this month? And having that kind of score live up there and showing that, hey, the morning shift's been 0% hazard all month, but the afternoon shift, they had, some more a reduction in their safety score because they did forget to wear the right PPE sometimes and stuff like that. That created a real friendly competition between different teams and shifts, so that they saw this big reduction in we benchmark it from when we turn the system on and it goes live. And that's when people first start realizing that there's this sort of guardian angel watching them, and their behavior changes just because they know that there's somebody or something keeping an eye out for safety. They start thinking twice about running across the room without the right mask on, right? That's
Yeah.
something that happened. He's like, I got to get from A to B. I don't have time to put on this mask. I'm just going to run across. That doesn't happen anymore because that gets tallied. And so that was our starting point with them. We saw initially 50% reduction in those non-compliant events, and it keeps going down. So their goal of hitting or let's say 100% safety score is getting very close, and it's been a big game changer because now they don't have to hire more safety um, managers and safety teams. They can keep their current team but expand their footprint in monitoring safety, and the EHS benefits in terms of reduced OSHA fines, reduced workmen's compensation claims. All those are coming true and provide real clear financial short-term benefits for doing this. How does that clear, Kudzai? Does that make sense?
Oh yeah, absolutely. So maybe to at the risk of kind of like getting too deep into the weeds here, so I want to kind of like get a sense of, I mean, a violation, a safety violation is not something that is sort of like universal, right, across different manufacturing environments. So I want to get a sense of how the accuracy of the training. Do you sort of like train your AI for a long period of time within that specific manufacturing environment before it could start accurately predicting, or I want to kind of like get a sense of what's the effort behind or how much data needs to be collected before you can start relying on the system to give you accurate predictions?
Yeah, that's a great question, and I can say right now, before we go into maybe a deeper dive later in this, I'd like to go into a deeper dive, but I do want to get to the other use case. I can just say that we have a proprietary sort of system that uses a lot of pre-trained and pre-learned relationship models. And so, for example, if there's a relationship with, let's say, someone wearing PPE or not in any different contexts, that idea of wearing something is sort of at a certain level represented in our model. And so we don't have to train our system again about what it means to wear something. Our system can just pick up, like, if there's new PPE that we haven't seen, and we have hard hats in there, we have safety vests, we have lots of different kinds of industrial manufacturing PPE already built in. So in certain cases, we just turn it on and it works. But if there is something unique, like a special kind of heat-proof jacket that they use, we do have a step where we teach our model to recognize that. And then once that's in there, once the jacket's in there, everything else just comes out of the safety sort of analysis system. And so, yeah, we were able to get things up really fast. I feel like getting a customer up with a new safety use case or any other use case, within 1 to 2 weeks, that's what we've been able to deliver, and that's really fast. But it only is possible because of our proprietary architecture.
Ah, interesting, interesting. Okay, so let's kind of like reserve that for a deep dive later on. So maybe you
Yes.
mentioned you've got another use case that you want to talk to us about?
Yeah, yeah. We talked about safety, alerting people when something is happening that they need to just take care of it right away in terms of safety. The other thing we do is quality. And I think people are really interested in quality and improving their yields. And so we have a customer that makes uh, vacuum press molded aluminum parts, from liquid aluminum. And there's some steps in that process that, if they are not done correctly and at the right time, will create imperfections in the part that could later cause it to fail. And those are not visible from the outside of the part. When the part comes out, it looks normal, right? It looks like it's a fine part, but there could be some mistakes in the actual molding process that could make it very weak, let's say, or have some other invisible defect. So this customer really wanted to know how often those teams that were making these parts were following the right procedure and how often they weren't. And what it comes down to is that this 10% in yield came out of us discovering that number of times that they were not following procedure, and then retraining everybody and giving real-time feedback. So like if they do it in a way that's not proper, they can find out right away that it is that they need to remember to do this process a little differently, like they were originally trained on. So that's that kind of feedback loop that can really, like with the safety, it can change the culture of care and craftsmanship and quality and also safety. You change that culture by giving quick feedback, and then that leads to, in some cases, millions of dollars of savings, because there was no other way to detect that quality issue. So that's a good example of our quality module in action. And combined with the safety module, because it's a very hot environment where they're molding aluminum, people have to wear the right PPE as well. And so you can combine those two in that environment and get sort of double the benefit, because you've got safety benefits and quality benefits from one sensor, and no one had to change the way they work, right? No one had to start punching these buttons, or no one had to, start wearing sensors. All that kind of more cumbersome, older technology not needed, and you still get the benefits. So yeah, that's the third use case.
Okay. So for this specific use case, do you perhaps have the numbers to say before your platform, kind of like what was the percentage bad quality that dropped off the production line? And
Yeah, yeah. So let's say if it was they didn't know exactly how often the
okay.
process was not being done. We discovered it was 15% of the of the units were made in a non-conforming way. And so we were able to see that drop down to 5%, and we hope to get it to zero. It's really no reason why it can't be 0%, but still, increasing that yield by 10%, or pulling off the defective units before they get shipped. That's a big deal. And so it's a really important thing to think about, like the increase in yield compounded by the number of things they're doing, right? There's just a multiplication there that's very powerful when you get to those kind of quality problems.
Yeah, absolutely. Absolutely. Okay, so maybe let's kind of like move on to the next topic here. So, I mean, what I find to be like one of the most significant benefits of bringing advanced AI technologies like Leela onto the manufacturing environment or the shop floor is this. I mean, as you have explained it, this possibility of then being able to operationalize the generated insights, right? And to kind of like make them relevant in the operational context. And that requires the AI platform to integrate with other manufacturing systems, both in the OT and IT domain. So what I would like to understand is how does Leela AI integrate with other systems? What mechanisms do you have available, or do you have any specific data connectivity standards that you use as well?
Yeah, yeah, we have added on pretty soon after we started the product an MQTT publisher, and it's flexible. We have our initial way of doing it, but we want to be open to working with all sorts of systems, and so we can create special kinds of topics and messages if customers require them to fit their needs. But the basics are that anything that our system detects, any event that's important, we can immediately publish on an MQTT topic a message with that event, and it has a timestamp in it. And even if it doesn't arrive immediately, it might arrive a certain number of seconds after the event happens. The correct timing is embedded in the event, and those are organized however the customer would like it. If they want the events organized topologically, based on which factory and then which workstation, which line within the factory and which workstation, we can set that all up in the beginning so that all the messages coming off our camera systems are really easy to organize in their structure. We're really open and will fit into anybody's architecture. And those can be used by other systems. So, for example, an MES system that's trying to really look not just at OEE, but also, let's say, OPE, overall process effectiveness, right? Now you're going beyond the machines and you're saying, let's look at, direct labor input. How much direct labor input was there? How much of it was value add? And then how does that coordinate with the bigger picture of a multiple stage line with lots of automation mixed in? That kind of use case is really powerful because now we can give them this high quality data as published MQTT messages for them to coordinate and correlate with the other data they're getting from all the other sources of data in their facility. So it really sort of really makes this beautiful connection between what people are doing and what the machines are doing, and sort of gets them both on the same level. Because right now, most I'd say the gross majority of places are not getting that kind of data, and so they're missing out on this opportunity to really improve because they can't get those signals. And with MQTT, it's really easy. It just looks like process started, process ended. Um, Quality problem detected, safety problem detected. All those are individual messages that can be received and processed by MES or a safety analysis system or a quality analysis system or an ERP system. Whatever wants to ingest the MQTT, they can use that.
Oh, that's interesting, and it sounds like I mean, so we if you have kind of like also noticed there's been a massive popularity of unified namespace architecture where MQTT is the core of that data architecture, and a lot of manufacturers that I speak with are also looking to say how best can we incorporate generated insights back into the unified namespace through MQTT. So it's super interesting that you have the capability to publish insights using an MQTT publisher into the unified namespace where all the different applications that need that information, they get it instantly across your entire enterprise, whether it's MES or it's a frontline worker kind of like needs that information. So that's really super
Yeah,
interesting.
yeah. I mean that's the enormous potential. If people start using our data points and building new applications on top of UNS and connecting those dots, it becomes a lot more of a realistic model of the actual world, right? You're not missing the parts of the world that you can't collect data on. You need the whole thing. And so this sort of unifies it and gives it a whole thing. And I guess we can talk later about digital twins, but I think this does also open up the doors to more realistic digital twins that are able to see beyond just simulations of machines. So there's another topic we can talk about down the road, but I'd say that the other thing about this OTIT and this sort of fabric that's connecting everything is that sometimes you really want your visual intelligence, like we were saying earlier, to use non-visual signals to make a decision, right? And so, for example, in some of our customers, they have, let's say, CNC machines, and the CNC machine is connected and it's digitized and it's sending great MQTT stream of messages about what's going on inside the CNC machine. So we can set up our system to receive those messages too, and then as we're interpreting the visual, we can throw this in as another variable in that computation. And so if the machine's running, or if it's not running, or if it's in a status code that is, let's say, some sort of error status code, the activity of the team around that machine the meaning of that activity changes.
Yeah.
And so, if there's a status code that's an error status code that requires immediate remediation, but no one's around, that absence of people means something different than if the machine's running fine and there's no one around. And so that's the kind of stuff we can do all the time with our customers is get messages and also get other data, like if we need to know what serial number is being worked on right now, or if we need to know what model is being assembled right now. If we can get that data from MQTT or other APIs, that really helps us do better connections with standard work, because big problem is, you know, what is standard work? What is the proper procedure and the proper duration of time to get some job done? And if you're in a high mix environment, standard work changes every few minutes if you're doing a new build every few minutes or every few hours. So that kind of integration with other systems like ERP systems and so on lets us connect the dots and understand the meaning of what people are doing in context of the standard work that they are being asked to do for that specific model and SKU at that time. So that's the real giant way to unlock value, is to connect everything and let the visual leverage all this other data that you've been working on, and vice versa. So it's a bidirectional connection, and we're really excited about the potential for that going forward with all of our customers.
Absolutely. That sounds really, really exciting and really powerful as well, because frankly, that's the future of digital manufacturing, kind of like having this system that are able to share information through these API interfaces, because for a long time we've had systems in manufacturing that kind of like a closed monolith where that insight is generated and it exists within that system, and then it's not of much utility across the entire enterprise. So it's really super interesting to know that you really uh, championing or fostering this open architecture with your systems. So
Yeah.
maybe let's kind of like move on here for our professionals or in the audience here who kind of like already wondering how that implementation roadmap looks like. So could you maybe describe a typical roadmap for implementing visual intelligence in manufacturing, starting from planning, deploying, and then also importantly, how do you scale that AI platform, Leela AI platform across multiple production areas, sites, or what have you?
Yeah, sure. I'll give you a typical sort of roadmap of that. First thing is we like to meet and do a bit of a dive into our customers' needs and problems and goals and stuff, and really picking the right KPIs. Um, Turns out a lot of our customers don't have a labor productivity KPI yet. They haven't tried implementing one, or if they do, it's not very accurate. So there's a little bit of work sometimes in figuring out what are the KPIs and the sub KPIs to really make sure that this will deliver the value, right? And can this visual agent really tell this user an actionable, situationally important information when they need to see it? This kind of real time sort of agent giving you the information you need. So we have to define what those agents need to do with the customer, and everyone's a little different. So as we talked earlier, right, we've got to have our system learn quickly on the job and have the agent, say the right things and provide the right KPI numbers at the right time. So there's a discovery process, discussion. What does success look like? What are short-term goals? What are the sustaining goals? Because again, you can make a change, and if you don't have systems in place to maintain it, things will go back to what they used to be. And so that's, I think, always true. And so we have also this idea of like, we need to do this right now, and then we need to do this to sustain it for many years. And we figure that all out first. And if we're doing MQTT stuff, we figure out what their architecture is, what kind of messages they need to see. Can they just take our standard messages and use them? So there's a lot of that kind of integration discussion with the MQTT stuff too. And we look at this, what is the SOP, and sometimes we have to set up stuff like single sign-on, because some of our customers really need our dashboard to support their corporate single sign-on. So we'll set up all that stuff too. So that's sort of the first week of discussions and setting things up. And then second week is installing cameras. We have one partner we've partnered with called Axis Communications. They make some really strong industrial IP cameras. So we can bring those in, or if customer has their own cameras, we can work with any modern IP camera. And if need to be, there's some cables that need to be run. So, the cameras need power over Ethernet, and those can be connected to some switches, and then depending on the architecture we have two options. We have an edge server that we can provide that does all the processing on the edge, or if not, just send it to the cloud if that works. So we have both options available. And then that's sort of the second week, let's say, although sometimes takes longer depending on the customer's speed of deployment. And then after that, we turn on our system. There's this thing we described where, if there are anything different that's new to us, we have to sort of train the model a little bit to recognize that stuff. And that can take 1 to 2 weeks. And then after that, we go live with, let's say, the first line. So and there's a lot of quality checks along the way that we do internally and also our customer does to make sure that we're all confident that this visual intelligence is actually intelligent. Because sometimes, if you're getting noisy data and garbage coming in, that just will propagate and become garbage out. And we don't want ever to have that happen. So we do have a very strong commitment to our quality and making sure that we know before we turn the system and go live that it's really, really accurate. So that's the process. And then you asked about scaling. Well, if there's a factory that has, let's say, 3 lines that are building the exact same product, and the process is the same, but the people are different every day. Well, the cool thing is you can just clone everything for the second and third line, and there's no more time needed to do any more configuration or training. It just works by just putting in the cameras and turning it on. Now, the next way to scale is, well, let's compare our factory in one country to our factory in a different country. And again, if the product's the same and the line's the same, you can just put the cameras up in the second factory in a different country or a different part of the same country. And then you get these cool benchmarks like, how is factory A doing compared to factory B? And then you get even more benefits because you may discover that there's something amazing in factory B that the people in factory A are now seeing and they can emulate. So that's kind of scale really increases the value we deliver because you can benchmark and then compare. And then, as you want to add more lines, you just keep on adding lines and we keep on doing this process. So, you can go from one facility to 10 facilities in a year, and then you get the benefits of scale. We offer volume discounts. You can get other kinds of benefits from just having that big picture view of the whole operation, so that you can have one screen where you can see, here's all my facilities, all my lines, and how they compare to each other and where there's great things happening. So that kind of view for a manual operation has been impossible to have until now. But with ours, we can do that. So yeah, does that answer the scale question, Kudzai?
Oh yeah, absolutely. I'm curious to find out when it comes to the hardware infrastructure, the edge server, are
Mm.
there any special kind of like requirements for your system to run on, or is it not one size fits all? Is it dependent on each
Yeah.
environment?
It depends a little bit on each environment. We standardized on a NVIDIA GPU based platform. So if somebody already has some NVIDIA GPU servers on site, they can use those, or we can help them, guide them to purchase the right servers. So yeah, our customers buy their servers. We install our platform on the servers, and and we scale it based on how many workstations they need to observe and collect data on, and take action on. So the more workstations, the more GPU cycles we need. So it sort of scales up pretty linearly with the number of cameras.
Okay, awesome. Awesome. So the other topic that I want us to touch on is that of skills and talent, right, for really working with these AI platforms. So over the past few months, I've been doing some research, preparing for this podcast just to get a sense of what manufacturers are struggling with, or kind of like what are they really working on as far as AI is concerned. And it was surprising to me that from the many reports that I read about the adoption of AI in manufacturing, the most common challenge in really scaling AI use cases raised by manufacturers was the lack of talent and skills. So first of all, I want to kind of like get your general take on that. And then specifically when it comes to Leela AI, what sort of skills are required to kind of like develop, maintain, or work with your platform, as it were?
Yeah, yeah, this is a very important topic. I think skill gaps are really really a big deal with all of the customers we talk to and in general in the manufacturing sector. And you know, it's possible in some cases to train someone who has some skills but needs new ones. And I think there's need to be more investment in that kind of training and professional continuing education on the job. Um, and yeah, I mean, in the old days, like somebody who had never written code to control a robot, sometimes you could get someone who would learn on the job how to program a robot. And that's an amazing thing to watch that kind of personal growth. I think the same process needs to happen for AI technologies. Um, People are hobbyists, maybe at home they're playing around with AI stuff, and then they come to work and say, "Hey, I want to try this at work." And they need to be encouraged, I think, and need to be given resources and given opportunities to grow. Because, I mean, I guess this comes back to the very beginning of our conversation. What is the most important thing to ensure the survival and growth of a manufacturing business right now? And I may be biased here, but I really do think having a really strong digital strategy, having really great digital transformation execution, and having the ability to apply uh, AI technologies like our visual intelligence technology in the right way to take it up to the next level, there's really not a lot of other options to increase productivity. This is pretty much the only option. So unless your team is on board and they're willing to learn, or you bring in new people who have those skills, executing that transformation plan is going to be really hard. And so I think investing in education, well, having people read all the material and look at the videos you've made, Kudzai. I mean, it's an incredible resource, and it should be required watching for a lot of people because it's available, it's free, and it's super powerful stuff. So we need more of people like you creating great resources, and then the management levels, the C suites. I think they need to look at their sort of digital readiness and skill sets across their organizations and intentionally say, let's invest here. Let's send people to classes. Let's get them some training. That's super important, and I don't think it's happening enough. So yeah, that's sort of the general take.
Yep.
And then in specifically with Leela, we've worked really hard to make our user experience um, I think approachable and intuitive to anybody who could be, someone who's never used AI before, and they're a supervisor on a line, and they're just trying to figure out how to, really solve some issues and really find the excellence and improve their line. So with us, all you need to learn how to use a web browser. You could say that, but there's actually a little bit more. You need to understand a little bit about all this data coming in and what it means. So in our dashboards, we have visualizations that are pretty intuitive. There's also the ability to download raw data. So it's like, oh, I see this trend data. If I download this and start doing my own very specific analyses, how do I do that? So there's some skills in downloading data sets from our web UI and doing things with them. And then they need to know a little bit about how to use data analysis tools, data visualization tools. So there's sort of a data fluency that is a really important skill. And some organizations have a lot of people with that. Others need a lot of training to get there. So that's one skill I'd say for Leela AI. For other things, like let's say they want to start measuring a new activity. So let's say somebody needs to track how often they're using a hammer to tap this pin in. and that activity wasn't in our standard data set. So we make it really easy for end users to just say, hey, I need to start tracking this new activity. And they just go on the screen and they highlight and say, this is an example of it. And there's another example. They give us 5 or 10 examples of an activity and they just hit submit. And then that goes into our backend. And we have this really nice workflow where we can add that new activity quickly. So it's not sort of out of the box set of activities that you always stuck with. You can add activities and you don't need to be a programmer or an AI data scientist to add them. You just need to be able to find them and click on them. So that's the other way that we can reduce the skill levels needed to use our platform. We made it really easy to use and made a web user interface for some of the more advanced features like adding new activities. So yeah, that makes it approachable.
Oh yeah, absolutely. I mean, I totally agree with you. I mean, as you mentioned previously, it's really about, developing this culture of using information to make decision, especially if you are dealing in an environment where pretty much a lot of the workforce are used to kind of like just using intuition in manufacturing. So really changing that culture to make sure that everyone understands that there is information that is available for them to be able to make informed decisions. So really, really great work that you're doing as far as enabling that. So the other thing that I want us to touch on before we wind down here is the AI technology behind Leela, which I really find fascinating. So, I mean, the technology was born out of a research project at MIT. So,
Mm-hmm.
I think that was pioneered initially by Marvin Minsky, correct me if I'm
Yep.
wrong, and then you
Yep.
later
True.
worked on it with your colleagues to bring it to market. And really, the idea behind it is that instead of like using only traditional neural networks for process monitoring, you combine it with the causal learning, which is pretty much an AI application for like how babies learn, right? So can you kind of like just break down that technology for us and maybe with kind of like a focus on what are the limitations of traditional neural networks and what are the advantages of combining them with the causal learning?
Yeah, sure. Traditional neural networks, they are really great at finding patterns in space and time. They have some weaknesses, which are becoming clearer and clearer, I think, to everybody, whether you're using ChatGPT or some other neural network system. And that is that they're not very good at dealing with outliers or edge cases or things that were not in their training set. And that's just because that's what they're good at. They're good at detecting patterns they've seen before. And so with looking at, let's say, video, you've got all these sequences of things that happening. And so you say, okay, every time someone uses a tool, I want to recognize that as tool use. Let's say there are 1,000 different tools that they could use, and there's another, let's say, 50,000 ways they could use those tools. So if you multiply that together, you say, okay, we need some training data. We need, let's say, 100 examples of tagged video for each of those specific combinations of tools and activities. Now you see the explosion of the number of kinds of training data you'll have to develop. And without some, unsupervised way of doing this, you need to have supervision, which means a human being has to say, that's when someone was tightening a screw on that type of device with that type of screwdriver. And then give me 100 examples of that. So you have to manually annotate that. And you see how it just grows crazily, the amount of training. To get a really strong model, you need to get enormous amounts of training data. So that's where we came to this idea of causal learning. And in causal learning systems, there's more of a symbolic way of understanding what's happening. So instead of saying this is a screwdriver and this is a rivet gun and this is that, you say these are tools. And once you've sort of done that, this network of knowledge, which is looking at cause and effect, can build a much more robust and flexible way of understanding the actions taking and the perceptions coming from that. That's sort of the beauty of the system. It is a complement to neural networks. We use neural networks to do the first stages of our analysis, but then those connect to this knowledge network. And the knowledge network has lots of more higher level knowledge and then can make better decisions and more robustly, even on data it's never seen before. So you could say, is that zero shot learning? It's a little different. It's more like combinatorial inferences based on combinations of existing knowledge, and you can combine those all sorts of different ways. So that's sort of at the core of our product is this causal network that has learned about cause and effect from seeing the world, and then able to apply that in to get much more accurate and faster learning. Right? We don't need thousands of video examples. We can do it with a couple, and then the rest is done at the causal layer to make the jump from small number of examples to accurate understanding. So I mean, I could go much deeper into the technology. We're a little bit short on time,
Yep.
but definitely happy to connect with your audience. If they're interested in how this works, they can reach out to us and contact us. Also happy to show people our product. If anybody wants to see how it works, we have some live demos that we can show people of the actual product too. So please get in touch with us if you'd like to see what we're doing with this technology for manufacturers. Definitely love to show it to you.
Oh yeah, absolutely. Yeah, we will certainly provide links to everything that we've discussed here today for anyone who's willing to explore that more and also to find out more about the AI technology behind the Leela platform. So we've actually run out of time now. So thank you so much, Cyrus, for taking the time to join us here today. I really appreciate it.
My great pleasure. And I hope to see some of you and your audience at some trade shows. We'll be going to a bunch of different trade shows this year. So come to our booth and visit us. We'll be at the Google booth in IMTS. So if you want to come meet me, come on down the 2024 IMTS show in Chicago, and I'd love to talk to you.
Awesome stuff. Thank you.
All right, take care, everybody.
Okay,
Thanks a lot.
bye.